Okay, good afternoon. Today's session will complete the remaining two problems from the practice. The first one is related to the reinforcement learning. Sorry, not reinforcement learning, regarding the recommenders that we have learned. So the problem gives you a table in which there are users and there are books. And users are given the ratings to some of the books, and some books they have not given the rating. So the idea of recommender is to predict whatever gaps are there, those this model can fill in. Let's have a look at the theory behind this topic. Okay, so essentially the model works as follows. So the model has parameters, that is the books or movies, they have got their features. So there is a feature vector. The feature vector consists of the actual features, that is x1 and x2. In this case, the movies can be romantic and the level of romanticism is captured by x1 and the fantasy level is captured by x2. In order for completeness of the model, this feature vector also contains the bias term. So the first term is always 1. So that is how this feature vector is formed. There is another vector which is the user parameter vector. So what are the user interests or user preferences, those are captured in this vector. So this theta vector is again for the individual person, and the rating given by a person for a particular book is given by the inner product of these two vectors or dot product of these two vectors. So theta transpose, that is user parameter vector transpose the feature vector for any pair, that is jth user and ith book or movie, gives you rating for that particular intersection or that particular cell. So the model tries to minimize the error in prediction. So this it does it by optimizing the values of theta. So there are two approaches. One is we have seen that in the class. So for solving the problem that we have in hand, the problem gives you the user vector which is predicted by this model, and you have to predict how much is the error in the prediction if the user parameters are as given. So let's read the problem and then solve it. The following table gives, so the grid is given to us with the books, users, and the feature vectors are given. And at intermediate step, decision parameter vector or the user parameter vector for one of the user, that is Anand, is given as given here. And you have to compute the error in predicting the rating by Anand for the book Machine Designed by Norton. So Machine Designed by Norton is already rated by Anand as 5. So we want to see whether what value of rating this is predicted by this particular model. So the rating predicted by model, as we see earlier, will be given by dot product of the parameter vector which is given and the feature vector for this particular book. So you have to form the feature vector for the book under consideration and take dot product with the user vector. You will get the prediction and the difference would be error. So that is the first part. And the second part is what should be the decision parameters. That is, the decision parameters are decided by the model as an intermediate level. But suppose you want, there are 3 books, and for all 3 books, you want 0 error in the prediction. So what should be these numbers? So it is just a theoretical question. In actual case, this is not the way optimization is done. But the second part will come after we complete the first part. Okay, so let me go to our solution sheet. So we know that theta for Anand is available to us. Is given as 0.14 and 0.5. me have both together. Okay, so we have to use this formula which will be faintly visible to you. So rating is given as transpose of user parameter vector multiplied by the feature vector. So in this case, we want to find out the rating for the book Machine Designed by Norton. That is the first row of the book. So first we have to establish for that Machine Designed by Norton what is the feature vector. So that will call as for the book Machine Designed by Norton. So can you tell me what will be the elements of this vector? The feature vector for the first book.
Sir, 1, 0.9, 0.1.
That's right. So first term is always 1. So the feature vector will, first term will be bias term. So it will be always 1. And the second and third will correspond, means the remaining terms will correspond to the features of that thing. So for the first book, it is 0.9 and 0.1. So it is 0.9 and 0.1. So now we can get the rating. So rating by Anand for Machine Designed by Norton would be given as theta Anand transpose multiplied by the X for Machine Designed by Norton. So tell me how, what is the value, and then we can calculate the error.
Sir, 3.75.
That's right. So this is 3.75. So that means error in prediction. That is the first part of the question. So the actual rating given by Anand is 5. The model is predicting 3.75. So it is 5 minus 3.75. So this would be 1.25. So this is the error. And this model works by predicting, in the sense it calculates the error for each pair of book and user and tries to minimize that error. So that is theory part that you can read further. But as far as this problem is concerned, the first part is over. Now you have to tell me how do we solve the second part. So what should be the decision parameter vector? So we want to know what are these parameters. So we want to know what is theta 0, theta 1 and theta 2 for Anand. If you want, so Anand has given here prediction for 3 books. So all the 3 books, we want error to be 0. That means we want perfect match for 3 books. So think and tell how do we solve this.
Sir, given three cases, we'll generate three equations. So three variables, three equations will give the solutions for theta 0, theta 1, theta 2.
Yeah, that's right. So in this case, the problem is solvable because the number of unknowns is equal to number of books. In a usual case, it will not be the case. So you will not be able to match perfectly by the method that we are doing it here. But in this case, just it is a academic exercise. So we are doing it that all the 3 books, if somebody wants to make perfect match, then it can be done in this specific case. So like we did here for Norton. So suppose theta 0, theta 1, theta 2 are the feature, the user parameter vector for Anand. Then for the first book, the rating is 5 and that should match equal to the theta 0 of Anand multiplied by the bias factor is 1 plus 0.9 times theta 1 plus zero point 0.1 times theta 2. Just like what we did here, same thing. except here theta 0, theta 1, theta 2 are unknown. Similarly, for the mark book, the rating is 4, and that is theta 0 plus zero point 0.8, theta 1 plus zero point 0.1, theta 2. And last book we have 1, so we have theta 0 plus, it is 0, so this term is 0 plus zero point 0.9 theta 2. So you have three simultaneous equations. So from that you can calculate how much is theta 0, how much is theta 1, and how much is theta 2. Just calculate and tell me the values. Minus 4.625, 10 minus 4.625, 10 and 6.25. Okay, yeah, that's right. I hope the other people are there and they are doing something. Can somebody confirm that you are getting the answer what Arshad is giving?
Yes, sir. Same answer.
Okay, I'll just wait for 2 minutes because other people may be. Okay, any question on this question? Okay, so let's proceed to the second problem. The second problem is for the reinforcement learning using the Q function method. Okay, so let's read the question. Okay, so the problem scenario is same as what we discussed in the classroom. So we have got 6 rooms and there is a robot in one of the room, and the performance measure is a robot how fast it can reach the charging room, the charging point which is in room number 3. So from given any of the states, so there are 6 states possible, how to reach from any of the states to room number 3. That is one of the state. That is the performance measure. So the reinforcement learning works on the basis of reward. So whenever there is no label, so whenever the agent takes any action, so in this case robot moves either to the right room, left room, up room or down room, the robot gets a reward. So that reward for every action is stored in what is known as reward function. So the reward function for this particular case, after the robot has roamed around the rooms for very large number of times, the reward function will be collected, so which is given here. So it is a very simple reward function that all rewards are 0 except for the rooms where the robot is entering into the charging room. So this is the reward function, and then you are having the Q function. So the concept of Q function is essentially you want to determine what is the way from reaching from any of the room to the charging room. So the direction or the first action that the user should take from any of the room is known as policy. So you have to decide the policy, that is given a state or given the room in which robot is lying, what is the immediately next action the robot should take. So that is policy. And second thing is every room, the policy is based on the value function, that is the probability that uh, one would reach the charging room from a certain room. So every room has got every room or every state has got a value, and the distribution of this is known as value function, and the policy is in a given room or a given state what action one should take. So the policy is related to both state and action, and the value is related to only state. The Q function is something which is allocated to every action. So for example, from state of room number 1 to state of room number 2, the queue function is defined as 75 and so on. So for every action, you will find that the queue function is defined, and there is a way to determine the value function from these queue function values, way to determine the policy from any state based on this queue function. And also, once that action is taken, the robo will get some reward as defined by the reward function, the at that instant whatever reward function is there. So based on the reward, the queue function value will be updated. So this problem, you have the at this instant what is the reward function, at this instant what is the queue function, and the question asks you calculate the optimal value function values. So this can be defined in terms of queue function. We will see that immediately. The second is what is the optimal policy for room number 5. So if the robot is in room number 5, that is this room, where it should go, whether it should go to the right, left, and so on. So that is what based on this queue function we have to decide. And the third thing is, if the robot moves from room number 2 to room number 5, then what, and it gets a reward as per the reward function, what should be the change in that direction. So it is moving from room number 2 to room number 5. So original queue function value is 77. So this 77 will get updated based on whatever reward it is getting and whatever are the value functions in the room in which it is entering. So the theory part or the governing equations which we'll be using are defined in this slide. So you have to only look at this bottom part. So the policy from any state, that is the best action from any state, is given in terms of the maximum value of Q function. So if you are in particular room, you can, so for example, if you are in room number 2, so from room number 2, you can go to the right, to the left, or to the bottom. So corresponding to right, left, and bottom, you have to calculate the Q functions, which in our problem Q function values are available. So for these 3 directions, one has to calculate the Q function. Whichever action gives you maximum value of Q function, that is the policy. So that is the way you should move. So that is first case. Means that is the way you will be solving the first problem. For solving the second problem, you will require that is you have to okay, that is actually second part of the problem. First part of the problem is to determine the optimum value function. So the optimum value function is defined in terms of Q function as to whatever state you are and whatever actions you can take from that state. What is the maximum value of Q? That becomes the value of that particular state. So if you are in room number 2, you have 3 directions to go. So out of these 3 directions, whatever is the maximum Q value becomes the value function value for that particular room. And the last part of the problem asks for updation of Q function. So the updation is done by using the rule which is given here. So whenever robot moves from one state S to another state S dash, the Q value along that action path will be revised as the reward it gets while moving by that path plus gamma. This gamma is the discount factor, so which is defined in the problem, multiplied by maximum of. So from S it has gone to S dash. So from room number 2 it has gone to room number 5. So with respect to room number 5, you will have another set of actions. So in this case, from room number 5 it can go to left, right, and top. So out of these 3 paths, which path has got the highest Q value? So that Q value multiplied by discount factor plus the reward it gets along this path will give you the modified value of that Q value along that path. So these 3 conditions we will be using. So let's move to our problem. So for the first sec, we require these bottom 2 equations. So this is the problem. The first problem is to determine the value functions for all the rooms. So we want to determine the value function for the first room. So star indicates its optimum value. The formulae which are given are for the optimum value, because value function will depend on what is the future path that you are taking. So V star for R1 would be given as, so I'm using the formula which is defined here. So let me just zoom this little. So I'm using the formula which is given here. So V star S is max among all the actions that you can take from a state. So you are in state R1. So from room R1, whatever actions you can take, that is the, so max of from room number R1. So when you are in room number R1, you can take two actions. Either you can move to the down or you can move to the right. So corresponding to these two paths, you have the Q function values. So Q for moving right and Q for moving down. So these are the only two paths which are available to you from room number R1. So whichever is maximum, that is what you are taking. So it will be maximum of, so what is the Q of right path? So Q of the right path is, so we are in room number R1. So right path is this. So the Q value corresponding to this path is 75. So this becomes 75. And the Q value for the bottom path, which is the second option available, is 60. So which means that the value function for this room would be equal to 75. So we get value function for R1 as 75. So similarly, we can calculate for the other rooms. So calculate for the other rooms and tell me that. So what will be the value function for room number 2?
At 95.
That's right. So from room number 2, so we are in room number 2. So we are here. So you have three paths. So here value is 95, another is 55, and another is 77. So the max out of these three is the value function here. So this becomes 95. So actually there is no calculation here. You just by observation you can tell. So what for room number 3? The room number 3 is itself as a gold state. So there is no value as such attributed here. So this is not applicable as such. Room number 4, what is the value?
80.
Room number 5
87.
and room number 6,
98.
98. So you can verify just quickly by looking at the problem. Okay, next we have to decide the optimal policy. So this is first part of the problem. The second part of the problem, we have to decide the optimal policy for room number 5. So you are in, let's say, room number 5. So room number 5 is this. So if you are in room number 5, what is the optimal policy? So from room number 5, you can take either upward direction, or you can take the left direction, or you can take the right direction. So out of these three directions, which is to be chosen has to be decided based on the equation which is written here. So it is argument max. So argument is A. So what action? The output of this function is the action, whereas the output of the bottom function is the value. So uh, you have to decide what action to take. So optimal policy from room number 5. So that would be given as pi star r phi, so that is the state, would be given as r max a of QAC. So there are the different states. So among this, you have to decide. So in this case, I'll just write it here. So R max A. So we have got three actions there. So the first action is going to the left, so which is 60. The second action is going to the top, which is 85. And third is 87, going to the right. So the output of this function is not the value, but it is the direction of action. So in this case, direction of movement. So out of this left arrow, right up arrow, and right arrow, you have to take that direction which has associated maximum Q value. So which direction what is the best policy from room number 5?
Going right.
Going right. So the right arrow has got the highest value 87. So that means move to the right. So remember that the policy is in terms of action and value is in terms of number. Okay, now the last question. So you have to update the Q function for moving from R2 to R5. So we are moving from room number 2 to room number 5. So the existing Q function is having value of 77. So you have to update once agent moves from room number 2 to room number 5. So in this process, room number 2 to room number 5, it will get an reward which is defined by the reward function. So the reward function states that the reward is 0 at this particular instant. So it gets the 0 award for this moment. So the updation rule, we will again look at our slide. So this is the updation function. So the updated value of the Q function will be given as reward plus gamma times maximum value of the Q function from the new state. So it would be given as Q function for R2 and in bottom directions, because that is what action 1 is taking, would be given as reward. So reward in this case is 0 plus the discount factor. If you refer to the question, the discount factor is given as 0.9. So discount factor is given as 0.9. So it will be 0.9 multiplied by the max value amongst all the possible actions from the new state. So from the new state, that is from room number 5, you can take 3 actions. The first actions, you can go up, you can go to left, and you can go to the right. So these are the 3 actions which are possible. So corresponding to left action, we have got Q function value, which is 60. Corresponding to up, you have 85. So 60 is for left, 85 is for up, and 87 is for right. So out of these 3 numbers, you have to take whatever is the maximum. So here A dash indicates the actions which are possible from the new state. So in this case, the 3 actions are possible. So remember that we are not taking actions from the original room, but from the destination room. So this will be 0 plus 0.9 into the highest of these terms. So that is 87. So this will be 78.3. So that is the way this problems can be solved. So essentially the queue function method updates the queue function. So it starts with some random queue function or all queue values as 0. And then as it traverses, takes various actions, it keeps on getting the rewards. So it keeps on storing those rewards and updates the queue function the way we did it. So originally the queue function is something arbitrary, but it will slowly start getting developed to the uh, right function or more accurate function by the updation rule which is given here. Yeah, so that there we come to the end of all the numerical practice problems, and the theory problems you can try on your own, and if you are in any difficulty we can means you can ask me or share on the classroom what your doubts are. Okay, so there we come to the end of our course. So there is no viva or submission is already done digitally. So we have, except doubt clearing from your side, or means there is no as such teaching is over for this particular course. And I have already declared the result of the project competition. So based on the combined performance for project 1 and project 2, so Amog, Harshad and Isha, so they have got the highest number. So I congratulate them, and I also appreciate the efforts taken by the others. So even some of you might have not really put thinking into the project, but might have done some work. Even if you have copied from somebody, that itself is 50% effort. So when you copy something, at least try to understand what has been copied, and that will help. Okay, so it's from my side, it's over. So if you have to say anything, you can. So since Harshad and Amog are there, they can tell if they want, they can share some experience about their project.
Sir, the overall course actually made us aware what the power of AI and ML are. So first we thought it could do everything, but now we know it is eventually what humans program it and the maths that governs it.
Yeah, good.
Sir, the project help us to apply the knowledge which you gave us during the lecture. Like we try to apply from the different point of view, and also the optimization method course helped us. Like there we had a hands-on programming for the Python project. So that's it.
That's right. So especially I appreciate Amok tried various things. Other people also tried, but Amok came to me at various times with various queries. And although his score in the second project was less, but he tried some 2-3 ways of solving it. He could not succeed to get the best score, but nevertheless the efforts were there. So I'm sure each of you will have your own stories. So somebody else would like to say something, not only project but anything, just on the spur of the moment. Okay, so we'll close at this point. And exam questions would be, I don't know, the pattern is not yet announced, but as I understand it is most likely to be of descriptive type. So in that case you have to prepare for means the conventional exam type of scenario. Again, this is unofficial, so don't say that it is not yet decided, but as I As I think I'm preparing for both MCQ as well as the objective type. Which one will be there will be decided by the authorities.
Sir,
Yeah.
sir, in case if it is MCQ, sir, would it be possible to club all the modules together?
What do you mean by all the modules? It will be covering all the modules.
Sir, no, sir. So all neural networks questions clubbed together, all linear regression clubbed together.
Usually, I shuffle the question. Mean the I tick mark the shuffling option, so every student gets in different order. So while making the question paper, I keep them together. If that is what you are asking, but every student gets in a different sequence. So if you refer to the question number which I gave to the question, you will get in that sequence. So in MCQ, I give every question a serial number. So if you go by serial number, you will get module wise most of the time.
Okay, sir.
Okay, Vijay, Viraj has got some interesting comment. Luck plays important role for machine learning models. That's true. Means I heard this statement from very senior professor of IIT Bombay who taught machine learning. He did not use the word luck, but he said it's lot of hard work and iterations. So it is not that you have a pakka theory for machine learning. It's, you know how neural network works, you know how backpropagation works. But what hyperparameters to set is very specific to every problem. If you have solved this machine crack propagation problem for mild means steel, somebody does on the copper, this whatever model you have learned or think that will work, it will not work in the another scenario. So it is the performance is not predictable. You for every case you have to put lot of efforts in order for it to work. Or if you have got like companies like Google and Amazon, they have got enormous data as well as enormous computational power. And today's with that computational power, you have the deep learning methods where you don't means all these iterations that you have to fine tune, they can be done. That is, the deep learning network will learn on its own what is the best, which are the best features which are to be discarded, and it works. Otherwise, the real-time voice recognition that Google Assistant does or Siri does is not possible. Okay. Okay. So all the best to all of you. And if you have any doubts, please come back. Okay. Thank you.
Thank you, sir.
Thank you, sir.